Welcome, students. In the previous video, we have defined independence of two events. In this video, we are going to study how do we proceed in the case when we have independence of more than two events. It's not immediately clear how do we proceed in the case, let's say, when we have independence of three events. Do we need the following condition, that the intersection of all three, probability of intersection of all three of these events should be equal to the product of their individual probabilities? Or do we need to look at intersection of any two of these? In other terms, do we need a requirement that probability of intersection of two events is equal to the product of their individual probabilities? And finally, probability of intersection B and C should be equal to the product of probability B multiplied by probability of C. All right, so in fact, this statement alone here is not enough to define the independence of three events, and these three statements alone are also not enough to define independence of three events. To define independence of three events, we need both of these statements at the same time. Let's take a look at the following definition. So n events are said to be independent if for every set of indices, a I1, I2, and so on through Ik between 1 and 1 inclusive, the probability of intersection of this is equal to the product of individual probabilities. So for instance, in the case when we are looking for independence of four events, we are going to require first that probability of intersection of all these four is equal to the product of individual probabilities, then probability of intersection of any three of those, then probability of intersection of any two of these is equal to product of their individual probabilities. Now let's take a look at the following example. So a protocol for making financial decision at a certain company follows the following circuit. So we have 6 financial analysts, and for a budget to pass, first it should be approved by first financial analyst. Then either it should be approved by financial analyst number 5, or it should be approved by or 2 or 3 and by 4. And finally, if it passes through 5 or this pass here, it should be approved by financial analyst number 6. Now, 1, 5, and 6 each has a 50% chance of saying yes. So probability that it will pass through 1 is 0.5, through 5, 0.5, and through 6 is also 0.5. 2, 3, and 4 will each concur with probability of 0.7. Now, if everyone comes to a decision independently, what is the probability that a budget will pass? So we are looking for probabilities that a budget will pass. Budget passes in the following case. So first, it must be approved by 1. Then it either should be approved by financial analyst number 5, or it should follow the circuit that is here, which is defined as 2 or 3 should approve. And if either 2 or 3 approve, then it should be approved by 4. And finally, it should be approved by 6. Now, if all of these financial analysts make their decision independently, then any intersection that we can imagine can be defined as the product of their individual probabilities. So that is, we can express the probability of the following intersection as probability that number one will approve, multiplied by probability of that event here. So let's just call it event B for now, multiplied by probability of number 6. Now let's calculate this probability here. Let's start off by looking at probability of 4 intersection with union of 2 and 3. So probability of 2 union 3 is defined as probability of 2 plus probability of 3 minus probability of their intersection. They make decision independently. We can express the probability of intersection as a product. Okay, great. Now this is equal to, this is number 2, which is 0.7. Number 3 is 0.7 minus 0.7 multiplied by 0.7. So this is 1.4 minus 0.49, which is 0.91. Okay, now we have union of that, we have intersection of that with number 4. So let's call this one as an event A. Then we're looking for probability of event A intersection with 4, which is defined as probability of A multiplied by probability of 4. So this is 0.91 multiplied by probability of 4 is equal to 0.7. Is equal to 0.7. So this is equal to 0.637. Okay, so right now we have calculated probability of A intersection with 4. We calculated that. Now we're looking for probability. Let's call this purple one as an event C. Then we're looking for probability of C union with 5, which is equal to probability of C plus probability of 5 minus probability of their intersection, which is expressed as a product. So this is 0.637 plus a probability of 5 is 0.5 minus 0.637 multiplied by 0.5. So which is equal to 0.8185. All right, now finally, we are looking for probability of intersection of 1 with, let's call this one as an event D with D and intersection with 6. Probability that 1 and 6 will pass the budget is equal to 0.5. So it is equal to 0.5 multiplied by 0.8185 multiplied by 0.5. So the answer is 0.205.